You sure you stay with me to the very end of this video? Okay, so let's go into the details. Okay, let's say we are giving this ordered pairs. We are giving this ordered pairs 2, 3. Okay, 5, 4. We have 0, 3, and we have 4 and 1. We're asked to find the mean of these other pairs. Now, the mean equals x values and the range equals y values. So these are x, these are y, these are x, these are y, these are x, these are y, these are x, these are y. So find the domain of these other pairs. It will be the x values, you arrange them in ascending order. So the least value of x is 0. Okay, after 0 you have 2. After 2 you have 4 and 5. So this will be the domain of this other pairs, whereas the range will be the y values, you arrange them in ascending order as well. So the y value, the least value there, we have it to be 1. We have 3. They are appearing to y. So when a number is appearing to y, don't repeat it, just write it once. If you write 1, 3, and 3, just write 1, 3, just one of it. Then the last value there is 4, and this will be the range of these ordered pairs. Okay, let me give you another problem to solve. Okay, you have this set of ordered pairs. You have 3, -1. Okay, you have 2, -2. Okay, you have 0, 2, and lastly you have 2 and 1. Okay, so feel free to pause this video and see if you can figure this out, find the domain and range. Okay, so let's do it together. The domain of this ordered pair will be the x value. So remember, this is our x, these are y, these are x, these are y, these are x, these are y, these are x, these are y. So domain, the s values, the least value of s value to be 0. We have 2. Okay, 2 is appearing to y, just take one of it, and lastly we have 3. So this will be the domain of this other pairs, whereas the range will be the y value. So to start from the least value, -2. Okay, we have -1, we have 1 and 2, and this will be the range of these ordered pairs. So this is how you can figure out or find the domain and range of ordered pairs. When f of x equals a linear, quadratic, or cubic function without fraction or radical, the domain of that function is said to be a real number from -infinity to +infinity. Let's look at some examples. We are given this linear function f of x equals 2x plus 9. So the name of this function will be a real number from -infinity to +infinity. So the linear function, the function with the hyper of x is 1, f of x is 1. So let's turn the example. We are given f of x equals this number quadratic function, the height of x is 3x squared plus 2x minus 3. So the name of this function will still be real numbers from -infinity to +infinity. So let's look at one more example. This number 1, a cubic function, the height of x is 3. So we have 5x cubed plus 3x squared plus 2x minus 5. So the name of this function will still be a real number from -infinity to +infinity. So this is how you present them in interval notation. So that's it for this. So when f of x equals a rational function, that's fraction without a radical or square root, the name of that function is said to be a real number not equals 0. That means x is not equals 0. So let's look at the simple example. We are given f of x equals 7 over x minus 3. So whenever you are given this kind of expression, First of all, don't consider the numerator value. You don't work with it, do as if it's not there. So you work with the denominator value. So it will be x minus 3 now equals 0. So make a the formula s now equal 3. When minus 3 equals change to 3, that means the domain of this function will be all numbers from negative infinity to positive infinity except 3, because 3 is the only number you can plug in here and the mass, it will result is 0. 3 minus 3 result is 0. So the numerator result is 0. So to represent this in interval notation as the main is going to be all numbers from negative infinity to 3 but not including 3 union values from 3 to positive infinity but not including 3. That will be the name of this function. Now let's one more example. Now this rule. Let's wipe this. Okay, so we are given this question. We are given f of x equals 3x plus 1 over x squared plus 5x plus 6. I asked to find the name of this function. Remember, now consider the numerator. So this is going to be x squared plus 5x plus 6 is now equal to 0. Okay, so you find the roots of, rather you factorize this quadratic expression. So when you factorize it, you're going to have x plus 3, x plus 2 is now equal to 0. Okay, so x plus 3 is now equal to 0 and x plus 2 is now equal to 0. Okay, so therefore the model of this function will be x is now equal to negative 3 and x is now equal to negative 2. So that will be the domain of this function, because only negative 3 and negative 2, then when you plug them in, this value of L and the mass that result to 0 is not meant to result to 0. So to represent this domain interval notation, we're going to be all numbers from negative infinity to negative 3 but not including 3, all values from negative 3 to negative 2 but not including negative 10, negative 2, union all values from negative 2 to positive infinity but not including negative 2. So that will be the domain of this function. When f of s equals a radical with that function or a square with that function, the domain of that function is said to be greater than or equals 0. So that means x is going to be greater than or equals 0. So let's look at a typical example. We're giving f of x equals roots of x minus, okay, so let's say 3. So how deep are the domain of this function? So when you have this kind of problem, you take the expression and it will be x minus 3 greater than or equals 0. So make the same formula here. So x will be greater than or equals 3. So this will be the domain of this function. To represent this in interval notation is going to give us array numbers from 3 to positive infinity. Note that we use this bracket when your number is included, but we use parentheses, and for instance this kind of representation when a number is not included. So take note of this difference. Okay, so let's look at one more example under this before I go to the next. So let's wipe this. Okay, let's say we are given this problem. F of x equals square roots of s squared minus 9x plus 20. Okay, so it's going to give you s squared minus 9x plus 20 is greater than or equals 0. So we factorize the main factor, is going to have x minus 5, x minus 4, okay, greater than or equals 0. So we're going to have x minus 5 greater than or equals 0 and x minus 4 greater than or equals 0. So you make a same formula. If you're going to have x is greater than or equals 5 and x is greater than or equals 4. So that will be the name of this function. Now to represent this in interval notation, so it's going to be array numbers from negative infinity to 4, including 4, union values from 5 to positive infinity, including 5. So that will be the domain of this function. So let's wipe this now, go and solve for the next rule. Let's explain the next rule. Okay, so the next two states that when f of x equals a rational function, that's a function with particle or square root at the denominator, the main is said to be greater than 0. That's x is said to be greater than 0. Okay, so let's look at a typical example. Given f of x equals 3x minus 5 over roots of x plus 2. So to find the limit of this function is going to be, normally it should have been x is greater than or equals 0 for this x when you figure the expression under the square root, but x cannot be, or 0 cannot be under the denominator, so that's why it has to be x greater than 0. So it will be x plus 2 greater than 0. Okay, so you make this formula. If you make it a formula, I'm going to give you x is greater than negative 2. So the limit of this function will be all real numbers from will be s greater than negative 2. So to represent this in interval notation, it will be all real numbers from negative 2 to relative infinity, but not including negative 2. Okay, so that will be the main of this function. So let's look at the last example I have here. Okay, let's say you have a problem like this: f of x, this is my land, equal rational function with square root at the numerator. You have square root of x plus 1 over x squared minus 9. So when you have this kind of problem, then you have two situations. First situation will be x plus 1 greater than equals 0, and x squared minus 9 not equals 0. So when you make the solid formula here, x is greater than equals negative 1. So for this x squared minus 9, if you factorize, you're going to have x plus 3, x minus 3 not equal 0. So we're going to have x plus 3 not equal 0 and x minus 3 not equal 0. Okay, so make a solid formula. I'm going to give you x not equal negative 3 and x is not equal 3. So this will be the limit of the function. How do you present this in interval notation? So to present it in interval notation, you're going to have two intersections. Okay, since for this particular problem, here x is going to equal negative 1, and here x is not equal negative 3. So that means we're not going to work with this negative 3. So to present this interval notation, is going to be all numbers from negative 1 to 3, but not including 3 union values from 3 to relative infinity, but not including 3. So that will be the domain of this function. So basically, this is how you can solve problem involving the domain of a function easily. Let's say we are given this rational function f of x equals 7 over x plus 3. I have to find the range of this function. Whenever you have a rational function like this, we are the numerator, you don't have a variable or an unknown in the numerator. For instance, in this question, you don't have like something like x here. You just have only 7, no variable attached to it. So the range of this function will be y will not be equal to 0. So the range of this function rather will be all real numbers from negative infinity to positive infinity except 0. So to represent it in interval notation, this is how you do it. All real numbers from negative infinity to 0, but not including 0 in your values from 0 to positive infinity, but not including 0. So that will be the range of this function. So let's wipe this now, solve another problem. Okay, let's say we are given f of x equals x minus 2 over 3 minus x, and we have to find the range of this function. Okay, so remember that f of x is something as y, so we have y equals x minus 2 over 3 minus x. Okay, when you have this kind of problem where you have a variable at the numerator, like here I have x as a variable in the numerator. So firstly, we have to express x in terms of y, so we cross multiply. So when you do it, you are going to have y multiply 3 minus x, okay, equals x minus 2. So when you simplify, you're going to have 3y minus xy equals x minus 2. So we want to make x the solid formula. So what we're going to do is that this 2 will come to the left hand side of the equation, and this minus xy will go to the right hand side of the equation. So we're going to have 3y minus 2 crossing over, we change to plus 2, then equals x minus xy crossing over, we change to plus xy. So when you factorize what we have here, we're going to have 3y plus 2 equals x in brackets, okay, 1 plus y. So when you multiply 1 plus y with x, you get back to this. Okay, so at this juncture, you divide both sides by 1 plus y. Okay, 1 plus y. Okay, so the new function of x equals 3y plus 2 over 1 plus y. And remember that for this kind of rational function, y not be equal to 0. So we have 1 plus y now equals 0. Okay, so you make y the solid formula. That means y now be equal to negative 1. When y equals to over, change to negative 1, right? So that means the range of this function will be all the numbers from negative infinity to positive infinity, but not including negative 1. So this is how you present it in interval notation. You're going to either write it like this: the range of the function, all the numbers not including negative 1, or you write it like this: all the numbers from negative infinity to negative 1, but not including negative 1 in your values from negative 1 to negative infinity, but not including negative 1. So that would be the range of this function. Why the domain of this function will be, remember, 3 minus x now equals 0. That means minus x now equals negative 3. So we have also minus 1. So x will now equal 3. So why the domain of this function will be all numbers from negative infinity to positive infinity except 3. The range of this function will be all numbers from negative infinity to positive infinity except negative 1. So that's it for this problem. F of x equals square root of x squared minus 4. And we're asked to find the range of this function. Okay, so firstly, let's get the domain. The domain of this function will be x squared minus 4 greater than equal 0. Okay, so x squared greater than equals 4. So you to make it the square formula here, you square both sides. So x is greater than equals 4. Sorry, greater than equals 2. Square root of 4 is 2. So that means the range of this function y equals square root of x squared minus 4 will be, when you plug in 2 here, will give you 4. 2 squared is 4 minus 4, 0. So the range of this function will be all the numbers from 0 to infinity, including 0. So that will be the range of this function. So let's write this and solve another problem. Okay, let's say we are given this function. We have f of x equals 1 over square root of x minus 3. So how do you find the range of this function? Remember, f of x minus y equals 1 over square root of x minus 3. So first of all, you have to make x express x in terms of y. So if you express x in terms of y, this multiply this, we're going to have y in brackets square root of x minus 3. Okay, equals 1. So to remove this square root, you square both sides. Okay, so this now cancels, so we're left with y squared times x minus 3 equal 1 squared still give us 1. So when you simplify this, then we're going to have y square x, okay, minus 3y square equals 1. So remember, we want to make x the square formula. So we're going to have first y square x equals 1 plus, when this goes over 3y square. So to make x the square formula, divide both sides by y square. So the x equals 1 plus 3y square over y square. So remember that y square has to be greater than 0. Okay, so you square both sides to make y the square formula. So when you square both sides, y will be greater than 0. So to find the range of this function, the range of this function will be all real numbers from 0 to infinity, but not including 0. So that will be the range of this function. Whereas if you find the limit of this function, the limit of this function will be, it will be x minus 3 greater than equals, sorry, greater than 0. So you make x the square formula, so x will be greater than 3. So if you have to write the limit of this function, the limit of this function will be all numbers from 3 to infinity, but not including 3. Whereas the range will be all numbers from 0 to infinity, but not including 0. So this basically you can find the range of the function. And with this, we are currently end the class. Hope that's not interesting.